For number 27, we are given that the charge is 0.3 microcoulombs and that the distance between the particles is 5 centimeters or 0.05 meters. First, we start out by drawing a diagram with such charges. And on part A, we are asked to find the net force on this charge. Now we first start out by trying to draw the direction of the force. So this is positive and positive, so they're gonna repel. This is positive, negative, so they're gonna attract. Positive, negative, so it's going to be attract. So this way, we don't have to worry too much about the signs. We first start out by defining that this is positive and this way is positive. We find the y component first, so we're going to look at this force and the component of this force that goes up like that much. So we're going to start out, this force is going to be negative because it points downwards, negative k q times 2q over the distance squared, and we're going to add, because it's pointing upwards, q 2q times k, the distance is going to be 0.2 times, not 0.2, square root of 2 times 0.05, all quantity square, and we're going to have to multiply root 2 over 2 because we're going to do the component and the angle is 45 degrees. Then we find the x component, so we're going to take a look at this little guy over here and this little guy over here. So we first do wait, I think this should be 2q. Yeah, so we start out by doing the force between this and this, 2q over the distance, 0.05 quantity squared, and then the force here is going to be k times q, 2q, square root of 2 times 0.05 quantity squared, times root 2 over 2 because we're looking at the horizontal component. So we get the answer, negative 0.05 and 0.17. To find the angle between these two, we have to do inverse tangent of the y over x. It's important to use not the rounded numbers such as these, but the exact numbers on your calculator, and that helps you get the correct answer. And then when you want the magnitude, you do y squared plus x squared, and you get 0.18 newtons. Part B asks for the electric field at the location of this. So now, instead of doing all the calculations again using the formula, we know the net force, and the electric field is going to be force divided by the charge. So it's going to be simple, that divided by 2q. For part C, we are asked to find the electric field at the center of the square. So we take a positively charged particle out of our pockets and place it in the middle. Positive, positive, repel, so force that way or field that way. Positive, negative, this way. Positive, negative, attract. Positive, positive, repel. So you can see here that the y components all cancel out. So this field, or the force, and this force are equal in magnitudes. And you know that this is going to equal this, but they're opposite. And this is going to cancel out this part. So all we have to look at is the x direction. And you can see that all of the x directions are this way, which is positive. So we're going to add everything up. So the electric field equation is going to be k times the charge over the distance squared. So we start out by doing k times q. So we're going to do this force over here. K times q over the distance, which is square root of 2 over 2 times 0.05, everything squared. So you get this. So square root of 2 over 2 times 0.05, because that's the distance between the two particles, times root 2 over 2 because we're doing the x component. We do the same for the field between this, and then we do the same for this and this and this and this, but only looking at the x component and multiplying everything by root 2 over 2. So just these two cancel, this cancels, this and this cancels, this and this cancels, and then when you plug everything in, you get this number. And it's important that it's the units is newtons per coulomb, and it's only going to be in the x direction, to the right. Y is going to be 0, and that's why we get this. And that is how you do number 12.